study whole thing. अभी तक हमारा जो more or less focus was on the theoretical and mathematical part of this thing. How can arrive at Dirac theory? Its solutions, positive solutions as well as. But we will not discuss what does it mean physically. जो whole thing हमारी है ना, जो physicality of the things, जो particle या antiparticle जो create हो रहे हैं system vacuum में, ठीक है? How we can relate them in some physical sense. Those positive as well as negative energy solutions. And negative energy solutions, we could map them to positrons and negative energy particles. अब ये है कि there is some physical problem. Physical problem हमारे पास ये है. अगर positive energy solutions भी है, and there are positive energy solutions. The other is so positive energy solutions का अपना field होगा, negative energy solutions का. So in principle we can assume that field में भी होगा positive field between electrons and negative field which is electron and positive fields which is electrons का opposite उसको positive होते हैं. अब यह है कि अगर electrons belong to sea of electrons and sea of positrons, ठीक है? One will constitute as positive energy solution, another will constitute as. अब अगर हम the problem is that Dirac sea consists of both positive energy solutions as well as negative energy solutions. The particles and antiparticles will coalesce. ठीक है? The stability of matter will be questioned. तो इसका मतलब यह है कि initially we assume that अगर positive energy solutions and जो negative energy solutions हैं, हम वहाँ assume करते हैं जो electrons हैं या positrons हैं, जो उसका field photon field के साथ interact नहीं करेंगे. ठीक है? If you assume that way, then you can rescue the stability of matter or things into consideration. Otherwise, there will be sort of problem in that sense. Problem इस हिसाब से आएगा, for example, for stable matter to study quantum mechanics, हम reactive transitions और calculating how they calculate, है ना? Energy level will be two successive states. Okay, that will explain for us transition from state A to state B. Photon आ रहा है, electron kicks into state 1 to state 2, or electron goes from upper state to lower state, in between it will submit photon. Okay, but we assume that intrinsically this is true for positive energy states. For negative energy states, अगर ये both Dirac sea maybe positive states as well, there will be problems with the mass. So इसको circumvent करने के लिए हम we prophesize that in negative energy states photons won't interact with the radiation field, does not interact with the electromagnetic. Okay. For example, अगर हमारे पास इसका स्टेट है mc स्क्वायर, so it will add mc square minus mc square. It will come out twice. अगर ये नेगेटिव स्टेट होगा उसका एनर्जी mc square है, because we say that Dirac field is composed of both positive energy states as well as negative energy states. अगर एक स्टेट की एनर्जी है mc square, negative energy state है mc square. So to make a transition from this to this, they will simply add up, and net energy will be twice mc square. Okay, in that sense. But it has some problem. Problem ये है, if you want to calculate it from we assume, so it will be from previous calculations of this. Also, if we assume that it's made over positive as well as negative energy states, जो इसका decay rate होगा ना, it's spent over 8 per second. वो कम टाइम तक ट्रांजिशन लगेगा, ठीक है? तो दिस इज नॉट सो how इस प्रॉब्लम को कैसे सर्कमवेंट करेंगे? If we don't have Pauline's exclusion, what's Pauline's exclusion? In the earlier class we said no to electrons or no to particles. The same still can be utilized at that. And इसकी later एक explanation आती है from symmetry. How we classify particles as symmetric or antisymmetric. From that we can have bosons or we can have fermions as well. अब ये है कि हमारे पास for example अगर diagram we want to show this is energy E, this is MC square. So in order to do away with this, like that, this should not be there. Electrons and these, they should not annihilate. So Dirac proposed a C of electrons, उसने कहा C of negative charge उसका positive charge, जिसको हम pole भी कहते हैं. So initially whole thing was not like there is another particle. It was later discovered. But he assumed that to include stability of matter, you should have holes also in that sense. And which circumvented जो हमारी Killing-Gordon equation थी. Killing-Gordon equation, if you remember, there were only which solutions? Only two positive solutions. Negative probabilities were not. So you can say Killing-Gordon equation may be a particular case of Dirac equation, which includes both positive energy solutions as well as, and also basically non-particle solution, one-particle state solution. So one-particle states can exist in two forms, either positive states or either negative states in that sense. So this was an explanation which was given by Dirac. Continued as a one-particle if you just read the argumentation of the book, he says, should we replace this Dirac equation by some another equation or not? So if you remember, in relativistic quantum mechanics, we assume जो base space है Fock space, which is infinite dimension space, it can be one particle states, two particle states, three particle states, and n particle states. ठीक है? But question is, if we replace Killing-Gordon equation with the Dirac equation, because Dirac equation includes not only positive energy states as well as negative energy states. Killing-Gordon equation में negative probabilities are done, but still it's a one particle state. एक ही किस्म का particle. इसमें positive state solutions हैं, yeah. But the particle is of, that's why it's one particle state. The particles are of the same kind. But you can also construct two particle states, three particle states, four particle states. So question is, should we replace Dirac equation, one particle states by some higher order particle as a subset of that? So if you read the discussion of the book, तो वो कह रहा नहीं. So it will be as an exercise आपने पढ़ना 2-3 sentences में what you do. Now there is something called charge conjugation. Charge conjugation means what? Charge. Well, each particle can have its own antiparticle. Charge same होगा, but उसका anti होगा. Then conjugate. So you should be able to, if we create an electron, it happens at the expense of some positron. इस जगह hole create होगा, दूसरी जगह electron create होगा. So there is sort of symmetry, sort of conjugation. Something is related. If I create here a positive particle and negative particle is created, a pair production takes place. You can explain it this way. Okay? So the charge conjugation. So electron is there. You can have simultaneous positron या hole create. अब question ये है कि how can these symmetry operations, whereby we can relate the conjugate properties of two pair of particles. Okay, so we have to study that symmetry operation. So for example, अगर हमारे पास मिरर इक्वेशन का एक सॉल्यूशन है for side, this is one solution. The other solution for its conjugate may be ये psi है, covered psi conjugate. Got a point? Now the thing is, how can, जिस तरह हम कहते हैं, there is a property in quantum mechanics में unitarity property is what? Unitarity or it's equal to, है ना, unitarity or unitarity is equal to. In the same way, you have to see how you can relate charge to its conjugate, and inversely from conjugate you can arrive at the charge. You should be able to flip this equation into this equation. There should be a way, or there should be some transformation by which you can relate this equation to its charge psi conjugate, its psi conjugation by some transformation rules, by some. अब ट्रांसफॉर्मेशन रूल्स क्या है? ट्रांसफॉर्मेशन रूल्स इफ यू रिमेंबर, हमारे पास जो सिग्मा था ना, सिग्मा स्पिन है ना, उसकी ओरिएंटेशन आ रही थी 4 मैट्रिसेस, कौन से 4x4 मैट्रिसेस, 0 1 1 0 सिग्मा 1 सिग्मा 2 सिग्मा 3 है ना, ऐसे गामा 5 आ रहा था इसके बराबर, गामा 0 गामा 1 गामा 2 गामा 3, ठीक है, या गामा 5 = 1 plus gamma. So how we can split? How can, अगर एक conjugate है, how can relate with the psi conjugate by some properties? And the properties are, for example, for a non-singular matrix. Before we have to say what's a non-singular matrix, you can say message. dx of x means to इसका डेरिवेटिव इसका conjugate, but when conjugate comes the माइनस फैक्टर comes out, डेरिवेशन में, ठीक है. इस तरह अगर गेज पोटेंशियल a mu है, it's equal to a mu dagger star. So how can relate this with this? So if you want to relate this, you can assume a non-singular matrix which is denoted as C gamma 0 with the algebra. Basically, algebra there से very, अगर आप इसका फिजिकल मीनिंग रखोगे ना, Clifford algebra, Dirac equation, all of Dirac equation is nothing but implementation of Clifford algebra on physical systems. Clifford algebra की अपनी algebraic properties होती हैं, but in those algebraic properties there are some geometrical constructions. जिस तरह वेक्टर है ना, वेक्टर आप ऐसे करोगे algebraically, but they correspond to some geometry. It's cross product, dot product. उसका visualization है, map है ना, from algebra to geometry. So in the same way, जो ये algebra है ना, इससे हम psi conjugate की properties को define करेंगे. But they correspond to some symmetry operations where particles and creation of antiparticles are related. So even though you apply these algebraic transformations, so in them are encoded some relations, and there is some physicality part of attached to it. Physically कुछ चीज हम देखते हैं, है ना? So C gamma 0. तो हमने ये डिफाइन किया तो C गामा 0. अब गामा 0 आप देखो मैट्रिक्स 4x4 मैट्रिक्स है किसका सिग्मा 0. C इज दिस, ये इसकी प्रॉपर्टी हम कैसे करते हैं. इस गामा इनवर्स इस गामा इज इक्वल टू गामा म्यू स्टार इज इक्वल टू गामा म्यू. ये आप कैन वेरीफाई करो. इफ यू टेक इट, सो यू इफ यू अप्लाई दिस these two equations, they will take this form. But you see here this C gamma 0. So you can write the C psi conjugate and psi conjugate. You can write it like this. Okay. Psi conjugate को बोले, so psi conjugate अगर you can also write it psi conjugate इसके बराबर. So we substitute here. So we have just rewritten this Dirac equation, conjugate form of Dirac equation in this form. This form. Okay. And which will correspond to positron wave. So अगर इलेक्ट्रॉन वेव फंक्शन इज psi, जो उसका psi कंजुगेट है, ठीक है, इट विल गिव अस अ positron wave function. So psi is related with psi conjugate via these transformation rules. But again, you can say let's see these properties. You can see here, it's gamma 0, gamma 0. Gamma mu 0 is equal to gamma mu transpose. This C है, ये gamma mu transpose is. So you अपनी जगह आप करना इसको gamma mu, so C, so gamma mu is equal to. So this is a C inverse यहाँ से. It will flip. This C will flip it back. So this is gamma mu is equal to gamma mu. जिस तरह है ना Hermitian is equal to Hermitian conjugate minus Hermitian conjugate. A mu is equal to minus A mu dagger. ठीक है? So and C can be considered. Let's say C inverse C dagger. So if we come back to our how we describe how we consider back how to find Xerox solutions. हमारे पास आ रहा है वो 1 0 0 0 0 1 0 0 0 0 0 1 उसकी जो 4 फॉर्म टू कंस्ट्रक्ट एज पॉजिटिव एनर्जी सॉल्यूशन वो क्या रहता है नेगेटिव एनर्जी सॉल्यूशन. So we have to see in simplest case how psi can be related to psi conjugate in a particular solution. Psi अगर particle है psi conjugate will be antiparticle. ठीक है. So there is a way in which psi is related to its psi conjugate and which will in turn embed in it the relations of particles as well as antiparticles. So psi का अगर हमारे पास ये है so the corresponding solutions for psi 4 is as 0 0 0 iota 0 0 iota 0 0 iota 0 0 minus iota 0 0 0 0 0 1. You see iota है बाहर है ना. If you multiply iota with iota, you have iota square. This will be minus 1. So if you minus 1, this will be plus 1. So you see. So देखो ये हमारे पास psi square. So this is the conjugate multiplication of psi squared psi with this. So ये हमारे पास it will come out to be जब psi conjugate आएगा ना यहाँ प्लस है ना minus. So psi is related. So we have a psi and psi is related to psi star with this I gamma है इस positive. But state है since it's split ये ऐसे है इसका ट्रांसपोज ऐसे है. So the relationship of psi and psi transpose so you can from this you can see electron at rest is equivalent to presence of we can say absence of spin down negative energy electron at rest is equal to presence of spin up positive energy positron at rest. So अगर एक चीज absence है, we can have other things also absent. So अगर positron rest पे है, electron will also rest. अगर electron का कोई spin up है, इसका positron का spin psi star is related to psi. Why this got transformed by these properties. So operate कर रहे हो, that's why इसका transpose है. Okay, this is the one. So this is how algebraically you can relate two Dirac equations. One is with psi, the other is psi conjugate. अब इसमें हमको एक चीज़ दिखी थी जो डिराक थ्योरी है ना, इन दो कैन थ्योरेटिकली जो मैंने कहा था कैन इन दो कंस्ट्रक्ट सॉल्यूशंस ऑफ वन पार्टिकल स्टेट्स। अब क्वेश्चन ये है कि जो डिराक थ्योरी से हमारे हमको ये पता चला एटलीस्ट इलेक्ट्रॉन का कोई किसी भी चार्ज पार्टिकल का एक एंटी पार्टिकल हो सकता है even of the same mass. So you can have in nature electron का same antiparticle होगा, ठीक है, of the same charge as well as same mass also, which are produced in particle accelerators. तो हम हाइड्रोजन एटम बनाते हैं ना, आप न्यूज़पेपर पढ़ते हैं, न्यूज़पेपर में न्यूज़ आई थी ना रिसेंटली 5-7 साल पहले, physicists have एक तो एटम है, they have made anti-atom तो हो गया मैटर, दूसरा हो गया तो एंटी मैटर में भी मेड को एटम प्रोटॉन का एंटी प्रोटॉन और उस इलेक्ट्रॉन का सो जो इलेक्ट्रॉन का एंटी इलेक्ट्रॉन होगा उसका सेम चार्ज होगा सेम मास होगा। सो वी हैव बीन एबल टू, ये बात एक तो थ्योरेटिकली है बट वी कैन डू समथिंग लैब में भी कर सकते हैं। तो हमारी जो मेंटल कंस्ट्रक्शंस है अबाउट स्मूथिंग, अबाउट हाउ टू सॉल्व ग्राफ इक्वेशन, इसका कंक्रीट रियलाइजेशन है फिजिकल यूनिवर्स में, ठीक है।